Accelerated Math Analysis, Lesson 12.3, picking back up with number 4. The video ended as we were investigating the sum of n terms of this sequence, where our first term, a sub 1, was a half, and our common ratio was also a half. You can see at the top of the screen here in green highlighted, we had our formula. I've recopied that down here. We can now find what the sum of adding up n terms will be. S sub n is going to be 1/2, and then we'll have 1 minus 1/2 to the n, and down below we'll have 1 minus 1/2. Now, of course, the very first thing I'm going to look at is this down here, that 1 minus 1/2 is actually 1/2 in and of itself. So we could write that this is 1/2 times, and up here we've got 1 minus 1/2 to the n, and down below we have this half. I hope you can see that these halves are going to cancel. Our sum then is plain and simply 1 minus 1/2 to the n. So adding up 3 terms, 5 terms, whatever it is, let n equal that term number, and you would get that sum of that number of terms. Let's quickly take a look at number 5. We're going to use our graphing calculator to help us out here. And, we have our sigma here. We're going to be adding up a geometric series where, our first term is 1/3, and our r is also 1/3. And you can see this is really what's happening. We can hit math, come all the way down to number 10, and you're free to use whatever variable you'd like. I'm going to use x, and I'll type in x equals 1, and up here we'll have 15. Then I'll hit alpha y equals, and get our 1/3. By the way, that's your first term that you see right there. Times, in parentheses, we'll have another alpha y equals, and we'll say here's another 1/3. Close our parentheses, arrow up to x minus 1, and right now your calculator will evaluate that for you. You can see as we punch this out, evidently about 0.499999. So getting very close to 1/2. So the big question is that really equal to a half? Is there some round-off error? Actually, we're exceptionally close to a half. We're going to investigate this issue about what's happening in the future on our next lesson, in fact. But we're going to see that this really isn't arriving at 1/2 at present. But sigma, though, just recapping, it was really just the nth term, that nth term formula that we saw in the first video. And that's really what's happening in this problem. Here we would have had a counter of n. We would have had n equals 1 to some specific number. So we've just got one last problem to take a look at. For number 6, please pay attention. You're not summing. You're not adding up. You're just trying to find the 20th term. Here's your first term. Here's your second term. In other words, we know a sub 1 is 2. If this is geometric, you can quickly take 6 divided by 2 and see that your r would be 3. You could confirm that very quickly. Your common ratio is a 3. And we're not summing right now. We'd just like to know what the 20th term is. So we've got to go back to the beginning of our lesson. A sub n is equal to a sub 1 times r to the n minus 1. And we'll have an a sub 1 of 2. Our r happens to be a 3. But if n is equal to 20, well, then this is 3 to the 20 minus 1. It's 3 to the 19th, multiplying that by 2. Now, what I want to make very clear to you is this is going to be very large. Obviously, 3 multiplied to itself 19 times, and then you double that, you're going to get something very, very big. So we have 2, 3, 2, 4. Then I think a 5 and a 2 and a 2. And then a 9, 3, 4. And that would be, amazingly, 2,324,522,934. Geometric series, if your r is larger than 1, can grow to be very large, as we can see. So hope things are going well for you.